So let's see if we can go through this guy a little bit quicker than last time. So r equals 2 over 2 minus 4 sine. So clearly it's still a polar because we have an r there. So everything's going to be an r theta. We certainly don't want to plug, 15, 20 different things in there for a sine and figure out what this thing's going to be. So we have some shortcuts. Steps over here on the side again. Solve the equation so it's 1 plus or minus whatever on the bottom. So this is the guy we want to turn into 1. Find the e, so we match it up with the equation here. E is this number right out there. So e is going to be a 2. Find the p-value, so e times p equals this number right out front. Plug in the e. Remember last time in the example we didn't really use that guy. It tells us our directrix. Sometimes we do, sometimes you can just ignore them. Determine which axis it's on. So it's a sine, so that means this p-value here will intersect the sine axis perpendicularly. Now, how will it do that? We look at the positive or negative sign here. It's a minus, so therefore it's going to be in rectangular, it'd be y equals -1/2. In polar, it's going to be, half away from the pole here. Okay, so we're done with that. Determine the shape. So E is 2. So we know E is C divided by A. So if this E is a 2, that means C is a bigger number than A. So that would mean coming out to the focus is bigger than going to the vertex. So this guy has to be a hyperbola. Now we need to go plug in 0, pi, pi over 2, and 3 pi over 2. These are going to give us points. Okay, you do these steps, you're guaranteed to get a good start on these. So if I go plug in a 0, I'm not going to use this one anymore. I'm going to go use this guy up here. I guess it really wouldn't matter in this case. Last time we didn't use the simplified one because this was a fraction. So it doesn't matter which one you use, it'll give you the same thing. So if I plug in a 0 for theta, that's going to give me 2 over 2 minus 4 sine of 0. If you're right here is nothing. So that entire thing is going to go away. That's going to turn to a 0. So 1, 0. Next, I'm going to go plug in a pi. So sine of pi is over here. It's the same thing. Sine of pi is 0. That entire thing goes away. I got a 0.1 pi. Next, I'm going to plug in a pi over 2. So sine of pi over 2 is up top. That's a 1. So this is 2 over 2 minus 4. So this gives us a -1. And lastly, I'm going to go plug in a 3 pi over 2. Three pi over 2 is down here. Sine of that is -1. So 2 minus 2 minus 4 is 2 over 6. So 1/3, 3/2. So I'm going to pause it here again real quick, grab those points, and transfer it over to a place where we can graph them. So what we found again, when we do these, are you found vertices, okay, or vertexes. So these 4 things are going to be vertices. So let's plot them and see what happens. 1 in the direction of 0. 1/3 in the direction of 3 pi over 2. So I'm going to change my scale on the y-axis into 1/3 for each one. So that's 1/3. 1 in the direction of pi, and -1 in the direction of pi over 2. So I got to tilt up pi over 2, and then I need to kick it -1 in the other direction. So 1/3, 2/3, 3/3. Okay, these are all vertices then. We said this guy was a hyperbola because E equals 2. And we said this P equals 1/2 is our directrix. Okay, it is a -2 sign, so that's going to put our directrix back here at -1/2. Okay, now our center has to be exactly halfway between this guy and this guy. So there's our center. So this is at 2/3, 3 pi over 2. All right. It is a hyperbola, so it's got to open going up in the y and coming down in the y through our vertices here. Because I encourage you guys to plug in these 4 points, sometimes, especially with hyperbolas, you may get extra points here. So once you find your center, you know this guy's got to come out this way through that point. This guy's got to come out this way. And we're basically going to do the same thing in the other direction. Just approximate your box here and bring these guys coming out this way as well. So the graphs aren't always going to look as sharp as they do in rectangular form. The most important thing is to be able to grab these right here. Here's a picture that's more to scale with everything. So notice what they did, and something that's real helpful you can do is they put these asymptotes in there through those vertices up here. So we can come from the center, we can put lines going that way, and that'll help bound things in the up and down direction, which you notice when I freehanded it, this guy's a lot narrower than this one down here. So what I'd like you to be able to do tonight is be able to go through these 6 steps, okay, and get the points. That's all something you guys should be able to do. Decide on the shape, and then we will work on how we graph these. Bring you guys' questions tomorrow.